Okay. Good evening, everyone. How you doing today? Okay, welcome to NYC Data Science Academy. My name is Carlos Gomez. I am part of an amazing admissions team. I definitely will be introducing everyone that's here in a few minutes. But today, our main speaker and presenter will be Eric Meyers. He's one of our alumni, and he is currently working as a data scientist for Change Healthcare. Okay. Now, before we get started, I just want to go over a couple of reasons why people are choosing our academy to become a data scientist. One of the first things I want to point out is that we have online boot camps and in-person boot camps. Our in-person boot camps is about 12 weeks. We have part-time and full-time online boot camps as well. We focus on data science, and we're the only boot camp that teaches both languages, Python and R. We have lifetime career assistance here at the Academy. We have 500 hiring partners, over 2,000 alumni, and our students, whether you come to online boot camp or in-person boot camp, they will complete 4 projects. These projects are the projects you can take with you to your employer as a portfolio to let them know the kind of work you did at the Academy. So the application process. If you're interested in finding out if you can be a good fit to our academy, one of the things you can do is go on our website, fill out an application, and once you fill out an application, you'll have an opportunity to schedule an appointment with one of our admissions officers, okay? Once you schedule an appointment with an admissions officer, you will have an interview. You can even have an info call. Once your interview is over and we've decided if the academy would be a good fit, the next step would be the tech assessment. The tech assessment will let us know if you have the foundations to move forward into our boot camp or if you would be a good candidate to get into our professional development courses. These are the upcoming starts. We have the spring session and the summer session, April 6th and July 6th. The deadline for both starts will be 2 weeks prior to the start. This is the team that we have here today. This is just some of us. We definitely have more people at hand. We have Dr. Paul Bao. He's our Director of Operations. We have Alex Baranski, our Bootcamp Coordinator. Monisa Felsen, Noah Escobar, Melissa Vilmene. We also have Pranjali, who's part of our marketing team. And I did see Thomas a little earlier as well. So without any further ado, I'd like to bring up Eric Meyers, our main speaker and presenter today.
Hi, everyone. Can you hear me all right back there? Cool. So hi, I'm Eric Meyers. I am a data scientist at Change Healthcare that I just started my new job last week. And I went to NYC Data Science Academy 2 cohorts ago. So I started on July 1st and then graduated on September 20th. So I'm gonna go through my, my capstone presentation. You know, afterwards, I'll also give you a little bit of details around, you know, the process leading up to, through the boot camp, and then, you know, even the job search afterwards to give you guys a little bit of a better handle on, you know, what's to expect through the process and also kind of what you can expect in terms of the work involved. Feel free to stop me at any point if you guys have any questions, comments, or anything of the sort. So I should actually start by saying where I was before this experience. I was working in media for you know, about 4 years. Worked my way up to the director level in analytics at a company called Universal McCann, pretty prominent company in the media industry. I was working with clients such as BMW, USPS, Shark Ninja vacuum cleaners, and CVS, and kind of working through a lot of analytics challenges through their reporting, automation, media measurement in terms of consumer behavior, research projects, and even doing a bit of clustering work. Some of my technical skill sets were, I already knew SQL really well from a prior role. And I used a bit of Java and a little bit of basic Python in order to automate some of my reporting processes. But I didn't, and I'd also worked with marketing scientists, which utilize a certain tool set of machine learning, but I only worked with them in terms of giving them clean data and working with them to go back to the business counterparts to help innovate and provide sort of data-led products that inferred business strategy. But I wasn't doing any of the heavy coding or the machine learning myself. So a big reason why I wanted to come here was because I wanted to both make a movement into the health industry. I felt like personally, I just wanted to make more of an impact towards innovation around people's healths and not necessarily, ad targeting, for instance. But also I wanted to get more hands-on with the technical skill sets, mostly around machine learning and especially where there's strategy and innovation. So that's what kind of sparked my movement into NYC Data Science Academy. And as I mentioned, 4 months later after I finished the boot camp, landed a job at Change Healthcare. So did what I wanted to. All right, so I'm gonna bring you through my capstone project. This is the last of the 4 projects. And this is basically where you kind of wanna pull together all of your experience that you gained through the program, and especially around machine learning, and then kind of present it in a way that ideally, helps you work towards your career goals. Another benefit outside of the bootcamp for the capstone is that you could really use it towards working towards your career goal. In interviews, a lot of people will want you to walk through a specific use case of how to demonstrate your skill set that you've picked up and something that you can bring to the table. So the capstone is a really good opportunity for you to speak both passionately and technically about the skills that you've gained and use it in the way that ideally may impact your career and also your work with that prospective company. So definitely keep that in mind as I bring you through this. Full caveat, before this, I had no healthcare experience whatsoever. So yeah, for what it's worth, if you're trying to make a career transition, hopefully I can give you some confidence to know that you can do that. All right, without further ado, I'll bring you through my capstone. Oops, did I just skip through? Do I have to pop out? Sorry. All right, so my capstone was about predicting congestive heart failure. My group, I had 2 teammates, Haoyun Zhang and Maite Herrero Garistiza, and we called ourselves the Naive Bays, of which statistics is a little, dorky clever. So my introduction is, going through the what, the why, and the how before we get into the more data-driven stuff. Talk a little bit about the data source, some of the mining and the decisions that we made in the process. The sexy stuff, the modeling, the types of classification and the risks and obstacles that come along with that. And then the conclusion and also a discussion about some of the future work that we'll be working on. This demonstrates roughly a pretty consistent flow of most data science driven projects, kind of first understanding what you're challenging, what you're trying to achieve, and then going through the data, understanding what risks or what might be missing, and then cleaning it, going through the modeling, and then kind of cycling through innovation around it. So why healthcare analytics? Firstly, it's already a very large industry. In 2019, the whole industry was considered $14 billion and looked at for very high growth. Also, it's where it's very open to innovation. There had been a lot of barriers around security, around healthcare records, and a lot of technical issues that, quite frankly, not a lot of people wanted excuse me, to deal with. But I think now finally doctors, hospitals, patients, especially in healthcare companies, are looking towards technology and data science to provide more efficient and smart ways to innovate around, all the processes and all the products around it. So there's a lot of focus around creating a cost-effective focus. And then also, especially on the image recognition, a lot of innovation that could help be able to predict people's diseases before they might even occur. So why specifically congestive heart failure? There's a high variability. So if anybody knows anybody who's had heart failure, it can be really hard to diagnose. There's a lot of common ailments that could also impact people, such as rapid weight loss, weight gain, just people just generally being tired and fatigued. And there's a lot of different conditions that could be the root at that. So it's notoriously pretty hard to predict unless a trained doctor is looking at an EKG scan and they see a very inflamed heart. And sometimes those barriers are quite expensive. So being able to predict this with just data can be a very impactful tool for doctors and hospitals to use and start to mitigate certain costs and also prevent people from going down a road where they're undiagnosed and continue to worsen their condition. Additionally, there's a high cost and also a large fatality rate associated with it. Most people that are diagnosed can be deceased within 4 years. So it's very important to catch that early as much as possible to try to take steps in both doctoral ways and also for doctors to give patients the information they need to improve their diet and also their workout behaviors. Sure. Yeah. So some of the main test indicators, as I mentioned, there's chest x-rays, electrocardiograms, and also there's a bunch of different lab tests such as blood gas, chemistry, and hematology. And additionally, there's familial history, gender, age, ethnicity, and income data that can start to insinuate what different risk factors might be predictors for congestive heart failure. What I'm going to focus on is what data I had access to. So I did not have any access to electrocardiogram or chest x-ray data, but I did have all of the blood lab results and also all of the affinity type of information, such as family history, gender, age, ethnicity, and income. So that's a lay of the land in terms of what the goals were and why and how. Now I'm going to get into the data source that we had. So the database we used was called the Mimic3, and it's a relatively popular example database that was built from a joint study between the MIT labs and the Beth Israel Deaconess Hospital. And this was a study that was conducted over about 11 years. And basically, the whole purpose was to use this database in an anonymized way that's HIPAA compliant, but still be able to give any sort of analysts, doctoral patients, or machine learning students the ability to have a test database to be able to create innovation around exactly what I was using this for. It was de-identified so that there's protection around people for health professionals. This is kind of a standard. There were 38,000 adult patients, about 45,000 patients in all, and it captured all of their visits, captured essentially all of their visits to the hospital. So one aspect of modeling that I'm going to go into a little bit more is, when you first come to machine learning, you kind of expect that all of your exercises are going to be for accuracy. You want to always get 100%. But as you learn, 100% is very rarely, realistic. And even if you can achieve that, most data scientists would be very skeptical and think like nothing's right 100% of the time, right? It's usually at best around like the mid 90s. But there's actually other metrics that you could optimize towards. And especially in this case, if you're predicting disease, you'd actually be far rather interested in having a sensitive model as opposed to an accurate model. And what I mean by that is if you predict that some people have the disease and they don't, that's still far better of a scenario because they can get a second check and a doctor can continue to look into it with them, versus the scenario that you predict someone's correct, someone has it and another person doesn't. Now the other person that doesn't, if they don't actually have it, or if they do have it, they're undiagnosed and they actually have a far greater risk of dying. So in the first case, you have a sensitive model, you're actually okay sometimes at predicting someone may have it even if they may not. That's what I mean by sensitivity. I'll get more into the details on that in a little bit. So extracting the data, as I mentioned, it was a quite robust database with 45,000 patients. This is across 26 different tables sitting in CSV format. Many of them were dictionaries, data dictionaries with ICD-9 codes that say, what disease, how it's classified, other data about admissions, all the other data I mentioned about different blood tests, people's age, gender, religion, etc. There were some complications. Two of the tables were gigantic, like 30 gigabytes size. Some of the measurement and conditions were not captured. When you go to a hospital, they don't give you 700 blood tests. They'll bring you through maybe the most popular 30. So there's definitely a lot of missingness. And also, due to compliance, some of the personal health records were de-identified, and that's due to HIPAA compliance and data compliance. So that presented a challenge because people under the age of 16 or over the age of 85, you don't actually know what their ages are. You just know that they're in that general bucket, which creates complications in modeling. Some of the solutions that we resolved with this, there were 26 tables, but we did a lot of joins for those of you who are familiar with how databases in SQL works. Fortunately, there was a good structure to the database, and there was a lot of foreign keys and primary keys. So being able to connect that data allowed us to pivot and create a pretty good data set to work from. Group by aggregation was really important because in some cases you have one patient, but in admissions, sometimes you have numerous patients. And what I mean by that is, I may go into the hospital once out of this 10-year period, or a second person may go 15 times. And each one of those, they have different records that you might need to aggregate in different ways. And then pivoting was super important, especially with the blood test results, being able to aggregate the data in a bunch of different ways. No data set is perfect. As I mentioned, there was a bunch of missingness and age calculations that were a whole to-do about how to deal with. But this actually is one of the most important parts, if not the most important part in the data science process, is being able to look at your data, analyze it, and clean it. Because without clean and organized data and well-structured data, you can never actually create a successful model. So we did different calculation imputations around age specifically, around the blood type measurements, and then we removed the bias of the data. And what I mean by that is we had indicators of whether or not a particular patient had passed away during their hospital stays or otherwise. And so we had to remove that because obviously if someone died, that's a good indication that, an unfortunate indication, but a strong indication that that person has some sort of disease that was the cause of that. So we had to remove those sort of biases about whether or not someone had passed away to make sure that our model was robust and not, biased. And then lastly, there was recategorizations of different determinants, such as language, marital status, and religion. The reason being, there's a lot of different languages. If there's only, for instance, one person that spoke Polish that went to this hospital, well, that's not really going to be an ideal indicator. Instead, I might say, oh, if there's one Polish person and 100 German people, and like 50 Russian people, I may bucket them all as Eastern European, for instance, in terms of language. And then lastly, in terms of the data set, one thing you'll learn here is how to handle different missingness. Sometimes there's a contingent reason why. I think one of the examples we used was if you're looking at sports data and you're trying to understand who the consumer might be, and you send out a survey to all of the all the potential sports bettors, sometimes there might be a lot of people missing. And if you send out a survey to a bunch of random people, it might help to know what people actually bet on sports. So there might be a difference between, for instance, how many females and how many males watch sports. And so you might incur that the missingness in this case might actually be more tied to gender than not. In some cases, there might be entirely, completely missing, entire random. So what we considered was the US health system has a tendency to overtest because there's people are lawsuit happy if you don't diagnose them correctly. So instead of imputing all of our missing values as the normal value for the database, we realized, well, this is a hospital. People are here because they're sick. So in some way, shape, or form. And so if the general population of the hospital is skewed one way or the other, we actually want to impute people's missing values as if they're healthy. It's kind of an assumption we made, but it actually played out very importantly at the end. So now on to the modeling phase. Actually, I'm sorry. One last thing I'll mention about imputation is another thing that you'll learn here is, there's sort of your classical models, such as linear regression, which most of you are probably familiar with, and then logistic regression. These are sort of linear-based models that require you to have imputed data. Everything I just mentioned carried through for our logistic regression. But tree-based models and some other more advanced models may actually still work with missing data. So I'll kind of bring you more through that in a little bit. But this is just to say that everything I just mentioned about imputation had to be done for logistic regression to even work. For all of our tree-based models, we use both data sets, the one with missing data and the one with imputed values, as it could handle that. Any questions so far before the modeling? Yeah.
Regarding the missing value imputation, you mentioned mean.
Mm-hmm.
But you have to look at the equivariate distribution of our data set and see
Yeah.
where the skewness.
Yep.
And
Yeah.
accordingly use the median or the mean value.
Yeah, definitely. So when we went through, that was a part of the whole pivoting process I mentioned. And as a part of that, right, that's a great point, because if someone only goes once, they don't have a distribution of blood type measurements, right? So that's a very important point. Thank you for bringing that up. So what we did was basically, if someone visited only, if a patient only visited one time, you would say that they have a maximum, minimum, and mean value, but they don't have your standard deviation or variance data. So what we assumed was basically the standard deviation was 1, and that the margin between their minimum, maximum, mean of the values that they had were as they were, versus someone who went, for instance, 15 times. You're able to deduce a distribution around all their different blood measurements, and then those became essentially their distributed values. Yeah, thank you. Any other questions before I go into modeling? Yes.
Who sourced the actual data for you?
So
Get your hands on.
yeah, so it actually, it was even though it's publicly available, you still have to apply and go through an approvals process. So I did, fortunately I had a head start just by talking in an interested fashion with one of my cohort mates who fortunately was working at a doctor's office. He was actually trying to make a change out of the health industry, but he had used this Mimic3 database before. And so a month before my capstone, he was like, dude, it takes a long time just to get access to this. So you should just, take a Sunday, spend a couple hours, go through some of the quizzes about, HIPAA compliance and other like human subjects training courses. It's about 3 hours. And then you submit a certificate and then you gain access to this database. At which point you could, you basically have a portal that you could log into that's, you need credentials for. And then you could download the the 26 tables, and then kind of more or less do whatever you want, but you also sign, you sign a release confirming that you're not going to try to go into the Beth Israel database and try to identify who these people are, or publicly disperse the data. You're using it for educational processes. Yeah. But thank you. That's also a very important point, where you're getting your data from. Absolutely.
Do you get it at patient ID level or it's,
Yes, did get patient ID level, but they anonymized it, so it wasn't using like their internal key at the hospital. So you shouldn't be able to de-identify it. But it was also accurate in that if there was one person's, if one person stayed 15 times, that one ID was still unique to them in this database. Yeah. I'm sorry, what? Perfect. That's perfectly way. So his question was or tell me if I'm wrong, but the question you asked was basically what inferred which models that I would use. Yep. So that's actually a perfect segue. So thank you. So this is a classification problem. And basically when you're looking at all types of machine learning problems, you can generally categorize them into 4 different buckets. The first barrier is whether or not it's supervised or unsupervised. And when people say unsupervised learning, they're referring to not having a specific target. So that's examples of that are clustering exercises, where you're looking at the data and asking the data to tell you how do people, or how do whatever data you're looking at categorize itself in a pattern that you may not be able to observe. Classification or linear problems are considered supervised learning, because you're basically specifically trying to identify a particular pattern, and what the type of pattern you're looking for. In this case, I'm going through a database and I have people labeled as having congestive heart failure. So this is a supervised model. And then within supervised, you have your classification, and then you have your linear models. So am I predicting housing prices that might vary from, say, $30,000 up to $7 million? That's a regression or a linear type model, versus classification is this happening or is this not happening? Does someone have congestive heart failure or do they not? That's classification. Yeah. You could definitely, yeah, with classification, you can use a linear or a nonlinear way of identifying the probability of someone, but essentially you're trying to predict whether or not they do or don't have something yet. Sorry? Yeah, yep, generalized linear models, yeah. And then within unsupervised, you'll have your sort of clustering algorithms, and then you also have dimensional reduction. I don't know if we'll be able to cover that last one, but if you come to this course, you'll learn all about it. All right. So I'm not going to go too much into this because I already did, but this is what I was mentioning about accuracy versus sensitivity. So for you more visual people like myself, basically an example is accuracy. You're going off of if you predicted, so predictions on the top and actual is on the left. Basically, if you predicted that someone does not have something and the actual is that they did not, and the prediction is yes and the actual is yes, basically this combined over all observations is your accuracy, right? So that's 150 over 165. That would be how to calculate your accuracy. But in this case, as I mentioned, you're really more interested in a sensitive model, which is accurately predicting of the people that actually do have it, how many of them can I predict yes? So that's 105 over, sorry, 100 over 105. Wait, sorry. Yes, yeah. So in the data set that we had, basically our default parameters, like we just ran this model without any optimization. And naturally, we got 80.1% accuracy for our logistic regression and 42% sensitivity. as I mentioned, we made some dumbification is a sort of technique that you have to use with categorical variables to make them seem as if they're numerical in a way. And then normalization, I just mentioned the process for that. So in terms of model optimization, through every model, there's different sorts of parameters that you use to sort of make your model more accurate. So I'm going to bring you through an example of logistic regression first and how we kind of fine tune this. So there's a parameter C, which is known as penalization. And basically this prevents a model from overfitting. If you guys have seen this, there's this example where, of a line chart where, the line just wobbles to every single data point. That's overfitting. And basically the issue with that, even if your line is 100% accurate, is that it can't generalize. So when it sees brand new data, you may show that same squiggly line, but it'll miss the mark almost every single time. In a very similar way, even though this is a logistic regression, in a very similar way, regularization finds that sweet spot where you don't overfit and you don't underfit. We tried both L1 and L2 regularization, where L2 we had a high C or a very low penalization, and L1 regularization where we had a very low C or high penalization. In scikit-learn, one of the most common libraries for machine learning, the ROC-AUC curve is basically synonymous with optimizing the model towards sensitivity as opposed to accuracy. And basically our job was to find our optimal C given a scoring of ROC-AUC using fivefolds cross-validation. I don't know if I'll have enough time to go into that, but if I do, I'll explain it more at the end. And then I'll explain the rest actually. So as we went through this process, refining our model, we identified that our best model had an accuracy of 82% and a sensitivity of 43%. So we didn't actually get much better than where we started. However, another feature of logistic regression specifically is that, as you mentioned, there's a probability that goes along with it, right? Logistic regression works with a sigmoid function, which is basically an S curve between 0 and 1 in terms of probability. So if something is more towards 1, or on your right side, I suppose, then the probability is much more likely that it will happen versus if it's less than 50%, it'll be more likely 0. However, you can actually customize that and change that. And because we had an imbalanced data set, where only about 25% of our patients were diagnosed with congestive heart failure, we actually found that moving that threshold to the left and down to about 26.3% actually really increased our sensitivity by a lot. So we actually roughly doubled our sensitivity up to 75%, which was our biggest optimization. The ROC-AUC, this is an example of the ROC curve. And basically, to get an 100% sensitive model, basically that would look like a big elbow up to the 1.0 up here. But this is just showing the area under the curve that covers about 76%, which is just a visual representation of the sensitivity that I just mentioned. Another good factor about logistic regression is it's highly interpretable. So the coefficients that you get as a result allow you to indicate what particular factors caused the model to exert a higher probability or lower probability that someone might have congestive heart failure. So just for a quick example, the red blood cell count and red blood cell standard deviation are on the low side. Magnesium mean is very on the high side. So how we interpreted this, and this kind of went back into some of our research and imputation methods that we did, is that people with low red blood cells, and especially a low variation of that red blood cell count, are very highly susceptible to congestive heart failure because they don't have the red blood cells that help them fight off infection, absorb oxygen into their body, and help a normal blood flow. And what that does is it congests the heart. It literally makes it swell up. Additionally, a saturation of magnesium or a depletion of potassium, I believe. I might have that backwards, but extremes of potassium or magnesium also causes the blood not to be able to flow correctly and the heart to pump as it normally does, again, causing the heart to inflame. So it was also good to know that we had like a sort of scientific backing behind our machine learning results. In the case of time, I'm gonna not go too much into this. Another model we tried was stochastic gradient descent. I'm not gonna go too much into it because it didn't actually work very well. But basically this utilizes some of the some similarities between logistic regression and trying to find the minimum error. And essentially still with the same purpose of refining our accuracy and sensitivity. But like I said, it didn't work as well. And if I have enough time at the end, I'll also go into a little bit more. Otherwise, it's also something that's covered very well here as well. The last optimization we did on both the stochastic gradient descent and the logistic regression was because we had an unbalanced data set where we only had about 25% of people that had it. There's a module that you can use called near miss. There's another one called SMOTE. And basically what they do is when you have an unbalanced data set, you could either over or under sample the majority or minority class to basically give this illusion of having a 50-50 split. This is actually comes more in handy when you have a really unbalanced data set, such as credit card companies trying to identify fraud. Because if you only have 1% of people that commit fraud, you can guess that no fraud happens and you'll be right 99% of the time. But that's not useful because then fraud still happens. So what you'd want to do is rebalance the data set whenever there's an unbalance, and that might actually give you better results. And in fact, it did. We got, I think, about 2% more, 2%, or no, actually, sorry, 5% more sensitivity, almost up to 80%. So that ended up being our best model in logistic regression. Any questions about logistic before I go over to tree-based models? Cool. And just a caveat, if this is a real life situation, we might have only used maybe 2 models, maybe logistic regression and XGBoost, for instance. But we had a little bit of time, and this was a bootcamp capstone, so we wanted to explore as much as we could through all these different models. And by doing that, we learned a lot through going through a real life example. So I think we netted out with about 6 different models, and it was incredibly helpful to be able to articulate the differences. So now our tree-based models. So we did 3 different tree-based models. And basically, all of these kind of hinge on the decision tree itself. Obviously, all 3 of these are vast extensions of a decision tree itself. But basically, the whole goal is to maximize the difference between your classes, people who do and don't have congestive heart failure in this example, and use the features that split it the most. So what I mean by that is, say for instance, all of the people that have congestive heart failure are above 75 years old, and all the people that don't are below 75. Obviously, this is not the case, but just for an example. If that was the most clear way to split the data, and by saying that people greater than 75 have congestive heart failure and people that don't, or that are younger don't, then all of these tree-based models would consistently say, basically ranked on the feature importance, that age would be our strongest feature. Again, this is to go through each individual model in detail would be way too much content for me to possibly cover. They're all 1 to 3 days of classes in the bootcamp. But that's essentially the basis for all tree-based models in terms of that splitting process. Random forest classifier is one of the, oh, sorry, one last thing is that you can use tree-based models in classification and also regression problems. I'm only going to cover the classification because that was what I did. So in random forest classifier, that Gini criterion is basically what I was just mentioning, splitting a tree at the highest ability to separate the classes. There's other features such as how many features, and sorry if I haven't clarified already, a feature is any of these variables or descriptors. So a random forest will only take a particular amount of some amount of them, in this case 8, and randomly samples different observations, and then uses each of those random observations to split out the trees. And that's how it sort of aggregates and then gives you this nice looking feature importance ranking. It's really interpretable in the way that you can start to see how different features impact the model. There's also minimal samples per leaf, which are those end nodes of the yes or no's that you get. The minimal sample split, and the number of estimators, meaning how many trees did you actually use to build this, optimal model. You'll see again our confusion matrices as we already went through, and these are the actual numbers. These are not samples. We did also use near miss and SMOTE, which we also realized afterwards wasn't completely necessary because tree-based models can actually handle imbalances of classes pretty well. But in terms of our results, we actually had pretty consistent results across all 3 tree-based models. Urea, nitrogen, glucose, and creatinine, and PO2, which is essentially like the elasticity of blood or how quickly it can clot, were all pretty consistently at the top of all of our feature importances for all 3 tree-based models. And again, found really good validation that these are pretty important predictors for insinuating whether or not someone might have congestive heart failure or not. Gradient boosts is also a tree-based model, but it's different, whereas a random forest would randomly sample, in that last case, 100 different trees. A gradient boost actually is sequential, meaning the second tree isn't just random compared to the one before it. It actually is built from the tree before it and seeks to reduce the error, which is where you get your gradient boosting name from. And it seeks to reduce that error towards the actual solution. So we even got a little bit more accurate with this one. Right, our best one was 85.6%, and our last, so about the same actually, for our gradient boost classifier. Many of the similar types of hyperparameters, well, you'll see that some of the results were a bit different. For instance, we had 500 trees in this one versus 100 trees in the random forest. You also have your learning rate, which tells you how quickly you approach that gradient minimum. And then Friedman MSE, which is a different criterion than your Gini criterion I just mentioned. But again, it seeks to minimize the error. And again, very similar results: urea, nitrogen, PO2, glucose, all on top. And then lastly, our most accurate model was our XGBoost. And if you've ever hung out on Kaggle or you've been reading like towards data science, you know, XGBoost has been sort of the popular kid the last 2 years. It's basically an XGBoost on crack, or sorry, a gradient boost on crack, in terms of the processing power and the methods that it takes to minimize the error. It's known best for being the most like the accuracy finder, but it's also very not interpretable to non-data people, notoriously. So if all you care about is accuracy, do XGBoosts and don't even care about anything else. But in a more realistic situation, you know, still try to use it if you need accuracy. But good luck explaining it to your coworkers. So we did actually find our most sensitive and most accurate model with 86.10% sensitivity and 85.76% accuracy. And again, pretty consistent in terms of which feature is designated the most important. This is just a chart to show the differences. And again, pretty similar on the top in terms of the glucose, PTT, urea, nitrogen, PO2, in terms of the feature importance across the random forest, gradient boost, and XGBoost. So in terms of our conclusion, obviously, being able to predict people's diseases is incredibly important and something that can really start to impact people's lives in a major way. But obviously, in the health industry, that has to be really well worked on. Like, this is nothing you could work on in 2 weeks and, you know, solve the whole world's problems. Like, I don't think any challenge is that easy. So if we were to actually build an actual product out of this, put it into hospitals, put it into doctors' hands, obviously a lot of careful thought would be needed around not just congestive heart failure, but all sorts of diseases. Also understanding that there was downfalls in terms of, you know, we made some quick assumptions and quick imputation methods, but if we had the chance to, we would have actually split out maybe adults versus children and had different models for them. Also, pregnant women medically have a lot of different extreme values in terms of how their blood tests may appear and their different vital signs. So that is something we didn't get a chance to look into, but we did enough research to know that that could have, if we knew that whether or not a woman was pregnant in our data, that we might have been able to break out 2 separate models to ideally have more accuracy in both of them. There was a couple other features as well. And this is just the beginning. You know, like I said, if we wanted to really make an accurate product and go to market with this, we'd actually need to do a lot of more medical research behind this as well. Obviously, there's approvals in the health system. Like, you can't just go into a hospital and start to put something like this into effect without a whole legal team and doctors and a bunch of other professionals to help do that. As my bibliography, this is more source information about the actual data set itself, some of the publications that went into the documentation, and other information about, you know, the reason behind PhysioNet and what caused them to build the Mimic3 database and put it public. And that is my capstone. Thank you, guys. So any questions about the actual project itself before I go to other things? Yeah.
So XGBoost versus linear regression. As I understand, XGBoost gave you better accuracy and better sensitivity. So my question is, if this were to be used in real world, would you choose logistic regression or XGBoost?
If this was real life, like if we were actually put this as a product into hospitals, we would use the XGBoost. Yeah. In this case, it was both the most accurate and sensitive. Yeah, so we would definitely like, if this was in a professional situation where, you know, I was a data scientist working with doctors and a legal team, I would still present everything because I think it helps. And I would also go through, you know, some of the content that, you know, we cover in the boot camp, because, you know, I had to consolidate this into basically like a 30-minute presentation, but productizing it, you know, as anybody who works in business or any sort of product knows, usually tech timelines for something like this would be like 2 years, right? And so that's long enough to be able to go through the very specifics around every single one of these hyperparameters, all of the assumptions we made, you know, really making it bulletproof. But I think on the modeling perspective, even just understanding like the differences between, you know, the ways that logistic regression works, random forest classifier and XGBoost, a gradient boost, and the differences between them and the similarities between them would definitely help make especially more of the abstract models like an XGBoost more solidified in how the non-data people, such as your lawyers and doctors, need to understand how they make that decision. Because if they're going to be using it as a product, or ideally like a tool or a second opinion to help them really diagnose people, they need to be confident and understand how it works, which not a lot of people do. So it would be your responsibility as a data scientist to really work in and explain how you came to the conclusion you got to. Yeah. Any other questions about the capstone?
Does it take care of the outliers? This models, the different models take care of the outliers?
So the logistic regression, for instance, has a harder time to do that Fortunately, because your target is between 0 and 1, it's fortunately not an issue with the target. And what I mean by that is like, again, like in a regression, a linear regression where you have like, for instance, housing prices. If most of your houses are between like 100,000 and 300,000, but you have one house that's $7 million, that would be a huge outlier, right? In this case, our outliers are really in the predictors, the actual variables themselves. We did some protection around that. Like if we found that someone's blood test was 0, then that, like they can't be, they would literally be dead. Or in some scales, in some blood tests. So in some cases we readjusted, but inevitably, we didn't have enough time to go through everyone's data. So there's definitely a possibility that there's certain outliers. With all the tree-based models, they would actually handle that probably better. Having outliers would actually probably strengthen the separation ability. But in some cases, there's possibilities that there would be an outlier with one particular data point that could screw it up, certainly. Yeah, it's always potentially an issue, yeah.
But the outliers are the things that, need the solution. So I think in medicine, me working with GMP, Sanofi, with Johnson & Johnson, outliers are something they look at.
Definitely.
Orphan drugs,
Absolutely.
For example, if you read the book Black Swan, that predicts a certain event in history, and what's going on right now with the healthcare. So it's an outlier that dictates the rest of the event that will happen.
Yeah, absolutely. And
so outliers are important. They keep it.
Absolutely.
We keep it too.
Yeah.
There's a different policy for that.
Definitely. If we had, like I mentioned, if we had more time, identifying where those outliers were and how to handle them properly and systematically would be incredibly important.
Like
And
30 years ago, John took your Princeton. We used to say, treat the outliers, but no more. Today's business, they keep the outliers. You have different policy, different medicine, different. So the outliers are important.
yeah, absolutely.
So I think I can get it. And for the solution, that's a big thing,
Yeah.
Hard for you.
Definitely.
Thanks, appreciate it.
Any other questions about the capstone? All right, so I know I mentioned a little bit about kind of my personal journey upwards. And I know these guys covered a little bit about kind of what to expect in terms of the admission process. But just to give you, a really brief kind of what happened after was, there's so much content that you learn within 3 months here, especially around the machine learning, big data, and deep learning tracks. And so personally, I had a little bit of time and money saved for me to be able to take my time and try to find the right job. I already had 7 years of career experience, even though it wasn't in the field that I wanted to move into. So that did give me some time to be able to re-review. So I took about a month of just going back through material at home and sometimes even coming in to both discuss with some of my other cohort mates and also test myself and continue to practice before I even started applying. I wanted to be ready for difficult questions and be able to answer them confidently, which I personally just didn't quite feel confident about at the time that I graduated. But I had personal strengths in having worked with marketing scientists before. So I knew like theoretically how everything works, but the coding itself I needed to work on, and especially the specifics around the ins and outs about different hyperparameter tuning and differences between models. I wanted to be a lot stronger at knowing what kind of position I wanted to get. So about a month in is when I started to really apply. And one thing that the bootcamp does really well is after about, I think the 4th week or the 5th week, there's a lot of it starts to kick off some of the professional workshops around, getting your resume together, your headshot, also thinking very critically about not just learning the information, but being able to explain it and talk about it, and the ins and outs and the challenges that come with each model, and different challenges that you might come up with. And there's also a lot of coding challenges, which at first they just suck, but they're super important because they're real life situations, especially if you want to work at your Googles, Facebooks, Amazons of the world. You are not getting one of those jobs without having a good rigor behind coding challenges. And just to be comfortable with that in a pretty safe environment is really vital, beyond just, you know, giving you practice for coding. So there's a lot of preparation in that case, and all of the material you could always go back to even after you graduate. So after that first month, that's when I started applying very heavily. And you know, there's a career support system here where you have a bunch of the different administrators, Alex included, and Vivian, who's the CTO, being copied on your emails. And if they can, if they know, there's a very extensive network, right? Like 2,000 alumni. So if you're very interested in a particular aspect, and you raise your hand and you make people aware of that, there's a good likelihood that you could be put into an interview situation, so long that you have, you know, roughly relevant experience, and you have the accreditation. So I interviewed for about 3 months, and then I got my offer around the end of January and just started working last week. So I flew out to Vancouver my first week of training, and just came back, and my role is actually remote. So I work out of my home with my dog. But yeah, any questions? I know Alex is up here and Pranjali's back there as well. So any questions about that, the process? And yes, please speak up. What makes it what?
What makes data science hard?
Hard? So personally, I wasn't very good at coding. Like I knew SQL really well, but you know, Python and R are, in my opinion, way much more extensive in terms of what you can do with them. So the coding especially was my particular challenge. I will also say I am personally a bit like mathematically inclined. I'm not like a genius, but I see stats or I see equations and I more or less kind of get what they mean. But some of the models have quite extensive statistics and theoretical understandings and caveats behind what makes them different, unique, or why you might choose one over another. That is something that you go through very deeply here, both like the coding and the statistics. So in my opinion, I think those two are the things that are very unique, that are very extensive, more than meets the eye. I don't know if you have, Alex, anything to add?
I can talk for way too long. I'll talk after.
Okay. If you have any other questions, if that didn't work, talk to Alex afterwards. Yeah.
So one of the benefits about this program that we like to say is that it's the only bootcamp that teaches both R and Python. But I guess what I want to ask is, in learning both of them coming out of this, do you feel like a little soft bake compared to like your career competitors that had learned maybe extensively only one, that you have to do a lot of remedial work and whatever your preferred language was at the end of this?
I would say I don't think I was at any disadvantage by any means. I think I only see it as better because in a lot of places, in any place that I've seen, actually, I don't think I remember a single company that only allows Python or only allows R. They kind of let you do your own thing, so long that you're proficient at one of them. And I only see it as an advantage because, especially if you're working on a team of data scientists or analysts, and some people will know Python, some people will know R, you're all the more versatile by knowing both. I will say most people tend to, by the time the bootcamp ends, people tend to favor one. It seems to me, at least, that people in either academia or something that's very statistically heavy generally tend to prefer R, versus Python is definitely more adaptable to like scraping or machine learning efficiency. and like, you know, your tech stacks and whatnot. But I only see it as an advantage, not as a disadvantage.
So you feel like they equally prepared you with both languages?
Yeah, you literally, like in terms of the learning modules, you literally learn like 1 week of machine learning in Python, or 1 or 2 weeks, and then you flip over and do the same thing in R. So you're equally as proficient. As I mentioned, like the only things that are different are like, you don't scrape, like web scrape in R, you web scrape in Python, but there's also different packages that you can choose from. Versus R, there's a couple of particular statistical tools that you can use that aren't in Python, but I'm sure someone is working on building out that library right now.
Do you touch base on stats at all? Like why the most?
No.
Because I teach at the university as a professor in machine learning.
Oh, okay.
We have Patterson, I teach machine learning. We get the license for all R, Python, SAS, SPS, SAS, Maya.
Okay.
That has a connection to R and Python.
Oh, cool.
And most companies, you know, on their marketing or like even Amazon, Google, they use SAS. SAS and R, I would say that. But I've been doing machine learning for AT&T, labs and Python, R, and
You definitely also learn a lot of SQL here as well. Like I said, I was already professional at it, but you get very extensive into SQL, but it's just a much shorter module like at the beginning. Then you can also get post work about it too. Any other question? Oh, good.
Sorry, I'm
That's
going to interrupt a bit. Since we also have some online audience, I want to take a pause here. All of us are going to be here. So if you have any more questions, please find us in the lobby, and we'll be more than happy to answer any questions you have individually as well as in a group. If you have any questions related to the Capstone presentation, feel free to grab Eric after the session. Feel free to connect with him on LinkedIn.
Yep.
And if you have any specific questions related to the bootcamp, Alex is going to answer them for you quickly, and then we are going to dismiss the session. And since you all signed up for this session, we also have some free swag to give away at the end of this. So do not leave until you
All right,
Oh, we're doing a raffle. So 15 of you are not everyone is going to get it, but 15 lucky winners.
All right, well, I just want to thank Eric again. Thank you very much, Eric, for coming.
Thank you.
All right, guys, so I'll answer any more general questions real quick and let Eric take a breath here. If you guys, so let me just introduce myself real quick. So my name's Alex. I'm the bootcamp coordinator for the residential bootcamp, which means that I'm going to be working with you, in terms of daily life, scheduling, things like that. I'm also an instructor. So I teach Python, which is like the Python module. So I get you started with the language, kind of break the code, get deeper into that, get you all ready for machine learning. And I also teach big data, which is at the end of the course. So I teach at the beginning and then the end, and then I kind of hang out and have fun in the middle. So if anyone has any questions more about the kind of overall program as a whole, I just want to touch one more thing on between Python and R. There's definitely an upward swing of Python being the more desirable language in the industry. But the way I like to look at it and the way that I like to explain to people is that R is really built by statisticians. So R is really meant to give you a lot of information about the models and things you create. This stuff is all baked in when you run them. So with Python, it'll be very difficult for you to run a model and then extract statistical stuff, or you need to actually physically install our packages to extract that kind of information. And that's because Python is built by computer scientists who just really care about efficiency. So there are two real different fields of thought kind of that gave rise to the languages. And so they're definitely applicable in different areas. But Python is definitely more desirable in the industry. That's the trend right now. But there's definitely areas where R excels, like, for example, looking at statistics for models. And also, I know that R is used very heavily in time series analysis, which is one that I find that's very popular. We also cover R Shiny, which is a great, it's an application. It's like a dashboard that allows the users to select things from your data. You can change your axes. You can filter by certain dates. You can make maps, interactive, buttons, things like that. I recently made one to control a scheduling program to essentially generate a schedule for like the next cohort, right? So it's like a really cool interface that you can use, and it's really useful for as an interviewing tool, because you can kind of, whatever project you've done, you can then use Shiny as a way to present your work, which looks more professional and looks pretty cool. So so I just wanted to touch on between R and Python a little bit more. So does anyone have any more general questions, and then we can break off and you guys can either get out of here or talk to me and attack me one-on-one. Yeah.
Is someone using Windows in this course going to be at a significant disadvantage?
Good question. So the question is, if someone who uses Windows is going to be a significant disadvantage. If you are not computer literate, I suggest getting a Mac. If you know what a directory is, you know how to open up command prompt, that's pretty much the extent of it, then you'll be fine with Windows. So Mac is a Unix-based system, which means that a lot of the stuff we do in terms of like coding and working in terminal and that kind of stuff, you can do directly through the terminal in Mac, which makes it very easy and simple to work with. Whereas if you are working with Windows, you have to install some third-party software, which makes things, sometimes there's connections that don't get made and there's errors, things like that. We'll work through those with you, but if you don't consider yourself a really computer literate person, I would recommend having a Mac if you don't have one already. Another thing that I want to bring up, that now you mentioned that, is that sometimes we have students that come to the program and their computer is like 6 years old and they've got their desktop is full of files, and they have like I don't know, some they have Internet Explorer installed, or if you're planning to take this program, buy a computer, invest in a $1,000 modern computer. It will make your life so much easier. You do not want to join this program and then spend 2 hours waiting for the program we're using to boot up, or it makes a huge difference in terms of quality of life and how much work you can get done. We cover a lot of material here. You do not want your computer to be the bottleneck. Okay, you already have enough on your plate. So spend the extra money, invest in a good machine, because it will be definitely, you will get more bang for your buck if you have a modern computer. Yes. Yeah, I can give you and essentially any modern computer with like at least an i5 processor and at least 8 gigs of RAM, maybe like 256 gigabytes solid state drive would be good. Yeah, if you guys want more specific specs, I can give it to you. But I would say at least an i5 processor. Pretty much any modern computer, as long as it's not like a Chromebook, should be pretty good. The Macs, you just go on their site and just click whatever one you can afford, essentially. But all the MacBooks are going to be of a high enough quality. But for a Windows machine, i5, at least 8 gigs of RAM, and then 256 solid state drive will make your computer really fast.
I just upgraded to a solid state drive for $200 with a computer that's 6 years old.
Yeah. Yeah, huge difference.
$200.
Yeah. If you have a computer and you want to make it faster, upgrade to a solid state drive. That's the best, probably the best bang for your buck in terms of upgrading it's so much faster, very worth it. Yeah.
So you're not involved in the online program, I guess?
So yeah, so the online program is going to be essentially recorded videos that you're watching, and there will be some kind of interaction with mentors, things like that. We have a mentor system. We have some great mentors that are really, really, really good. You guys are working on the same projects that we will be working on, and then generally we try to get the online students to work together on some of the group projects. So something I should bring up are the 4 projects that we work on in this bootcamp, which I'm really proud of because they are really very, very comprehensive projects. So the first 2 projects are going to be, one is going to be in R, one is going to be in Python. The R project is a Shiny project. You pick a data set, you do some data analysis, and you build a Shiny app to explore the data set. So the first 2 projects are going to be heavily reliant on your data analysis skills. So the second project is in Python, and that's going to be a web scraping project where you scrape data from online, you use that data set, and then you do data analysis on that data set. So they're meant for two main things. One, so that you're proficient with the language, so that you are able to use the language and know the most popular tools, things like that, how to manipulate data sets, how to do visualization, things like that. Because machine learning is going to require a lot of concentration, and if you're fumbling with, like what is a what are the primitive data types in Python, it's going to be too much to absorb all at once. So those projects are meant to really make sure you're comprehensive with your understanding is comprehensive. And then 2 is to work on your data analysis skills. Data analysis is something that we try to focus on here because a lot of people think, oh, I want to learn machine learning. I want to make this machine learning model that makes all these predictions for me. But a lot of people don't understand that data analysis is a huge part of machine learning because you need to understand how the data interacts with itself and how the data interacts with the world in order to make a model that actually makes sense. And you can interpret the model in a way that isn't just, I'm going to shove some numbers in here and get some numbers back. That's something that we call a black box, which is generally not going to fly in most industries. So you need to be able to understand why you're using a model and what the model is telling you beyond just the numbers it spits out. And that's you need to be able to inspect the data to do that. Did I answer your question or did I just completely? Yes. Okay. Yeah.
Do you want to speak to the last 2 projects?
Oh yeah, sure. Yeah, so the last 2 projects. So I should mention those. The last 2 projects are the group projects. The first of so the third project is a Kaggle competition. It's an open competition now, which means that you won't be winning any money for it. But the idea of the project, and actually, if you saw some students kind of hanging around, they're working on it right now. The idea of the project is to predict housing prices in a bunch of houses in Iowa. And it's really more of a sandbox project for you guys to really, turn on the jets when it comes to using machine learning, because the students now are in have just finished their first or second week of machine learning, and now they're starting to just throw things on the wall, apply things that they just learned, and see how much they can do with these new tools that they've been taught. So this project is more of an exploratory project in machine learning, so you can get comfortable with it. Because by the time you get to your capstone project, which was the last project, you should be ready to go, because the capstone project is the crown jewel on your portfolio, which is going to be most of the time what you're talking about with employers. So that's going to be your artillery shell, your ammunition when you are talking to potential employers. The capstone project, we have corporate partners that come that will work with you on a real life problem that they're having that they need help with, or we have data sets that we've chosen and can kind of give you research questions, things like that about real, like for example, like how do you predict when someone's going to default on a loan, or if you approve someone for, how do you detect credit card fraud? Like these are very, very popular machine learning tasks that are quite difficult. So the capstone project is something where you're essentially going to do something in 3 to 4. You're going to do something in about 3 or 2 to 3 weeks that most teams will take about 3 to 4 months to complete. So it's super, super intense, but we need to make sure that you guys are there and have the skills to do this kind of work. And it's something that you guys should be proud of when you leave. A lot of people come to our bootcamp, they've never coded before, and then they leave with this incredible project where they solve some machine learning task, or give some advice to new mothers about how to keep their baby safe, or real practical information, practical insight from data that they've collected. So the capstone project is the last one, and that's the one that you should really be prepared for by the end of the program, and that's the one that's really going to send it home when you're talking to employers. Rogerly's giving me eyes over here, so she's probably going to kick me off. Yeah, one more question. Yeah. So if you're in the in-person boot camp, so the question is, do you always have instructors in person? If you are in the residential boot camp, we are always here. Yeah, so we are always here, even when we're not teaching. If you guys have questions, we're either back in the office or we're hanging around. So we are a resource for you. It's a very intense program. I can't stress that enough, but it's incredibly rewarding, and we're here to help you. And it's the longest and shortest 3 months of your life probably. And but we are really, all the instructors here are great. I love working with them. They're all really passionate in helping people understand and learn about this stuff, because it is difficult. But yes, we are always here in the back or hanging around or like sitting in on classes, so we'll be here as a resource for you. And we also have fantastic TAs, I should mention too. They're not here right now, but we have a great selection of TAs to help as well. Yes. So generally per cohort, we have 50 students. There's about 25 per room. That's the max that we can legally have in the classroom. So that's for in-person. Yeah, there's no limit to online. The online is not limited.
Online conducted at
So the in-person runs every quarter. So there's one in starts in January. There's one that starts in spring. There's one that starts in summer, and there's one that starts in fall. The online, I believe, are running once a. There's eight per year, and you guys can look at the schedules on the website. Those start dates are on the website. Okay. Okay. If you're interested in applying, apply. There's no fee. I'll grade your tech assessment, so I'll keep an eye out for you guys. So yeah, it's just a really easy process. If you're interested in doing it, give us a call. Just start the process because there's no risk, and you never know. It might be for you, and it might change your life. So you know, give it a try. Yes.
What does the tech assessment consist of?
Okay, that's a good question. So when I say tech assessment, don't be too worried. Okay, the tech assessment is used for us to understand if you want to join our program. One, how can we help you best? And two, is this the right program for you? Okay. So we're not using the tech assessment to say, oh, you know, you're not smart enough, or, you know, you need to go to a different place. We want to know, is this the right place for you, right? Are you going to be wasting your money coming here? We don't want you to waste your money. If you are looking to move into data science, how can we help you best, right? So the tech assessment is essentially one theoretical and two kind of coding technical questions, and then more of a feedback question about our lectures and to see if our lecture style is meshes well with your learning style. So if you don't have any coding background or you've never coded before, don't worry. Give us your thought process. I want to know how you think, right? How would you approach this problem? Because even if you haven't learned to code before, I can tell a lot about someone's aptitude in the future of their coding career if you can tell me kind of how you would approach a problem and whether you could think about it logically and kind of iterate through the steps of how you would approach the problem. Okay, so don't be too worried about the text. Just do your best. Yeah.
The machine learning part, is there any prerequisites, like in terms of statistics or maths, which
Sure. Yeah, that.
helpful before coming?
Yeah, that's a great question. So absolutely. So the question is are there any prerequisites for the machine learning part in particular? And there is stuff in the pre-work for machine learning, but everyone generally seems to overlook that part or not prepare enough, because that's the part where a lot of people struggle generally in the program. And that's because the pre-work is mostly focused on programming, and a lot of the probability and the stats and the math is kind of more about, like, you know, reading like textbooks pages, things like that, watching some either like Khan Academy videos, things like that. So a lot of people don't really put enough emphasis on that, but it is incredibly important, if not more important, because you can really get lost during the machine learning portion if you don't catch up on that. So what I would recommend is don't overlook that in the pre-work if you decide to join. But the bare minimum, I would say, is you need to make sure that you're comfortable with linear algebra. So like matrix multiplication, maybe eigenvalues and eigenvectors. Just the concept of vectors and matrix multiplication should be enough. So like the dot product. It'd be helpful to know kind of different mathematical symbols, like a summation, like the, you know, sigma, you know, like what is x hat, what is y bar, that kind of stuff. For statistics, I would recommend knowing just distributions, like what is a distribution, what types of distributions are there. That would be very helpful. And then for probability, maybe Bayes' theorem, although we cover it in the boot camp. Unfortunately, you guys, it doesn't seem like you guys got Eric's naive Bayes title joke, but you'll get that once you join the program. But yeah, so a lot of that stuff is in the pre-work, but those would be the bare minimum, because the machine learning portion, which is about halfway through the boot camp, things really take off at that point, because you're not only working with the language, but now you're learning this stuff that really isn't gone into in depth in the pre-work. So it's very difficult at that point. Okay.
Thank you, Alex. So we'll be taking rest of the questions in the lobby. I just wanted to maybe conclude this by saying, and thanking everyone for coming here tonight. We have one of these here. This basically has a summary of everything that's mentioned about the job prospects, about the learning path. Go on our website and probably download the syllabus, and you will get everything in detail. We will also have more information about the online data science bootcamp, and we'll be starting, the next bootcamp is starting on April 6th. So in case you're interested in the data science industry, maybe you would want to do it now or in the next 6 months or 1 year, I think you should, start with this curriculum and then download it. It also has code that you can use when you apply for the bootcamp. You might also get some free resources. So get one of these, get hold of one of the admissions officers, and they will be able to tell you more. I also have names of people who are getting the swag. So it is Alexander, Jesse, Aida Ramos, Nick, David, John, Tomas, Marlon, Elizabeth.